So, areas of parallelograms and trapeziums. Okay, let's have a look. Well, first of all, let's start with the starter. Calculate the area of this composite shape. Pause the video, work out the area, and then off you go. You might want to break it into smaller shapes, okay? Just like we did before. So, unpause the video when you're done. Okay, so we have unpaused the video. Now, I suspect that you probably were sensible and cut the shape across there. To make a triangle, we'll call that A, and a rectangle, we'll call that B. Now, the area of A will be base times height divided by 2. Now, the base of my triangle here, well, let's look. If the whole base is 30 and this bit is 22, then this part here must be 8 meters, okay, across the base of my triangle. And if the whole height of the shape is 20, but the rectangle's 15, well, the difference between those is 5. So it must be 5 meters to the top of the triangle. Now, that will be a right angle in there as well, even though my drawing's a bit squiffy. So base is 8, height is 5, multiply those together and halve it. 8 5s are 40, divided by 2 is 20. But what are my units? We're working in meters and we're area, so it's meters squared. So that's the area of A. B is a rectangle, so we've got the height of the rectangle, we've got the length, or length and width. We need that kind of L shape that completely covers all the full height and the full width of my rectangle. And we do length times width, or whatever you want to call them. 30 times by 15 is, or 3 15s are 45, but it was really 30 times 15, so it's 450 meters squared. And so the area of the whole shape will be the combination of those two. So 20, things got all funny again. 20 plus 450 equals, come on computer, catch up, 470 meters squared. Okay, let's move on. So we're going to look at, first of all, area of parallelograms, because they're pretty straightforward, actually. And let's remind ourselves, again, we know with a rectangle, we know that we usually call one side the length and one side the width. And if I want the area, I would do the length times the width. We've got that full kind of L shape that covers the full length and width of my rectangle. Now, a parallelogram is very much like a rectangle, except, it's had a bit of an accident. It's been knocked over, okay? So it's just like a rectangle that's been knocked over. It has a couple of interesting features. It's flat. Woohoo, not very interesting maybe. But it's also has 4 sides, yep, and 2 pairs of parallel sides. So the top is parallel to the bottom, and that side is parallel to that side. Okay, so it's just like a rectangle that's been knocked over. And if we just get rid of those markings for a second, we usually call one side the base, and the other dimension we want is the height. We don't want any slopey sides. It's just like a triangle in a way, that we want the height, the distance from the base to the top. No slopey sides. Okay, and actually the area in that case is actually quite straightforward. It's base times height. That base times the height, not base times slopey side. No. Base times the height, the distance from the bottom to the top. We ignore any slopey sides. Let's do it. So calculate the area of these parallelograms. Okay, so I've got the base. The base is obviously all the way across. So let's put area equals 8 times by the height. That's not 3. 3 is a slopey side. We want the height going straight up at a right angle, which is 2. So it's 16 meters squared. It's meters because the dimensions are in meters. Obviously, it's area, so it's meters squared. Okay, base times height, and that's it. No divided by 2, that's triangles. This is just base times height. So this one, what's the base? Well, there's no measurement here. Well, it's a parallelogram, isn't it? So we know the opposite sides are equal, which means the base is 9. And I don't want 6. That's a slopey side. I want the height. So area equals base of 9 times by the height of 5 9 5s are 45. Yeah, see? Parallelogram's pretty straightforward, really. And again, it's meters squared on this one. Your turn. There's 2 just for you to work out, please. Please write them down. Don't just do them in your head. Remember your units. Unpause when you've done those. Okay, you've unpaused. Right, area equals base, 9, times by the height, which is 6. I know this is on the side, but it's not actually the slopey side. This arrow is indicating that it's actually the height, the distance right from the bottom to the top. Did that throw you? Hope not. 54, oh, working in meters again, so meters squared. Area of this one, we've got 3 dimensions, but we know we don't want this. That's the slopey side. We want the base of 10 times by the height of 5. So that is 50 meters squared. All of these have been in meters. Odd. Right, in that case, just 4 more for you to do, and then we'll move on to trapeziums, which are a bit more exciting. So pause the video, unpause when you've done. Make sure you do write all this down nice and neatly in your bestest handwriting. Number 1. So area equals the base of 6 times a height of 4, which that is the height, isn't it? Straight from the bottom to the top. Makes a right angle with the base, which is 24 centimeters this time, but it's still squared because it's area. Number 2. The area of number 2 is 8 times by the height of 2, which is 16 centimeters squared. Now number 3, let's have a look. We've got a slopey side. Don't want that. Don't want slopey sides. 5 times by 3, which is 15 centimeters squared. Okay. And number 4. Again, don't want the slopey side. Not bothered by that. We just want the base times by the height. The base is 4. The height of it is 5. So that's 20 centimeters squared. Ooh, not very neat that. Okay, right, that's parallelogram. So just remember you need that base and you need that height. Okay? Right, let us move on to trapeziums. First question. What is a trapezium? What makes it special? Well, a trapezium can come in all different sort of shapes, actually. There's quite a variety of trapeziums, and they only really have a couple of things in common. And that's a trapezium. And it's a 2D shape, so it's flat. It has 4 sides. So far, it's just like a parallelogram. Except this time, it only has 1 pair of parallel sides. Okay? 1 pair of parallel sides, which means this is a parallelogram. Look, there's a pair of parallel sides. That's what the arrows mean. None of the other sides are parallel because look, if I carried on this line here, and carried on this line, they would meet eventually. So they are not parallel. So 1 pair of parallel sides. So this is a trapezium. All of these are trapeziums. Look, they've all got. I don't know why I've got a pause there. There's a pair of parallel sides. Nothing else is parallel. I know we got a few different bits and pieces on these. I don't know why there's a pause sign. What's that about? I'm not pausing. Parallel sides, 4-sided shape. Parallel sides, 4-sided shape. Okay. So let's move on. Finding the area of a trapezium. Now this can seem a bit tricky. There's kind of 3 steps to it, really. And the first one is we add the parallel sides together. So I'm going to add together my 3 and my 7. Okay, 3 plus 7 is 10, right? I then multiply that by the height. Now remember what we said about the height of the parallelogram. It's that height that makes a right angle with the base, goes up, posh word for that, perpendicular, straight up. The distance between the 2 parallel sides, really. So, I'm getting ahead of myself there. So 10 times by the height is 40. And then lastly, as I just put over here, divide by 2. You halve it. So take that 40, divide it by 2, which is 20, and my units are centimeters squared in this case. Right, so you add the parallel sides, multiply by the height, and divide by 2. Now this height, you can think of it really as the distance between the sides, because that's what it is. That's what the height is. Because remember, if I turn this trapezium, turn this trapezium on its side, it wouldn't look like the height, it would be straight across, but it'd still be the distance between them. So that's another way of thinking of what we mean by the height. Okay, and it can look like this, because actually, let's think. This is doing exactly the same thing I'm doing. Adding my parallel sides, that's A plus B. Timesing it by the height, whatever the answer to that is, and then halving it. But you could still write it down in 3 steps if you wanted. I might do both here. Now my parallel sides are here. 12 and 17, not 13. That's the slopey side. So 12 plus 17 equals 29. I then times that by the height. You can use a calculator for this. The height here is 9. That's the distance between them. Like you can see that. If I carried on a little dotted line, see that's the distance between those two sides. I'm going to use a calculator for that. 261. And then I'm going to halve that to get, presumably, oops, oh, 130.5. 130.5. So, don't forget your units, centimeters squared in this case. Add your parallel sides, times that by the height, so the distance between them, and then halve it. And that's your trapezium, okay? Right, I want you to try the same thing here, so just follow that little list of stuff. Come on, honestly, have a go. Don't. I don't want to hear any of them. Oh, I don't know what I'm doing. Just follow this little tick list. Remember, these two are the parallel sides. Right, unpause when you've done that, please. Cool, right, I hope you're nice and strong, resilient there, and hope some people even went, oh, that's a bit easy. So add those parallel sides. 25. Times that by the distance between them, the height as we call it, which is 10. So that's 250. And then you halve it, which equals 125 centimeters squared. Okay, I just want to talk about this formula a little bit before I sort of move on. Because if you want to put it in a calculator, you can just put it straight in as a big sort of fraction. So that last one, I would have done, opened up a bracket and done 14, come on computer, plus 11. And putting that in a bracket, that will mean that that calculates first. And then that will be times by the height, which is 10. And I would have probably set it up as a fraction in my calculator where it divides it by 2. Or maybe just put divide by 2. And it would have straight away given me the answer of 125 centimeters. So there is a formula for this, and there it is. It looks a bit complicated, but it's basically doing those 3 steps we're saying. But you can quite easily just write them out separately. Okay, what have we got here then? One more for me to do, but hang on, there's top and bottom different. What's going on? Well, it's no different really. It's still one pair of parallel sides. So my area will be, well, I'm not going to work out the area straight away. I'm going to do the little 3-step method. I like that. So 8 and 11 are my 2 parallel sides. So I add them to get 19. I then times that by the distance between them. Well, that distance between them, we can see, look, it's at right angles there, so it's 4. So that is definitely the distance between them. I think that's 76. It's a while since I've done my 19 times table, but yeah, it is 76. And then you halve that to get 38. Oh, sorry, that's a divide by 2, which is 38 centimeters squared. Add the parallel sides, times by the distance between them, and halve it. Okay. Your turn. That's what that says under there. 2 more for you to have a little go at. Unpause when you're done. Just follow the 3 little steps. Okay, you're done. I'm just going to change to a blue pen because I actually prefer it. Add the parallel sides. So the arrows tell you which sides are parallel. So 8 plus 2 is 10. Oh, that says equals 10. Then 10 times that by the height between them. Not 9, that's the slopey side. I don't want that. I just want the distance between them. 10 times 6, 60. If you're not sure, go back and listen to my explanation again if you're not sure. And then we're going to halve that to get 30. Okay, and when we're confident with this, when we're back in the classroom, I'll probably show you why this sort of method works. But for now, I think we'll just we'll stick with what we've got here. Okay, this one, the parallel sides. There they are, going straight up this time. They're parallel because they've got the arrows on them. Add them together. That's what it says. That's 40. And then times that by the distance between them. This is definitely the distance between them because it comes off at a right angle. So it's 20. Right, 2 4s are 8. And then I've got 2 zeros. So that's 800. But you can use a calculator. That's fine. And then 800, divide that by 2. You always halve it at the end, just like you do with a triangle, to get 400 centimeters squared. That's a big one. Okay. Right. Now time for some practice. Okay, I think we're going to presume on here that there is a right angle in there. Otherwise, I want you to pause the video and work out the area of all 4 of these, please. Make sure you're writing down your working out. Okay. From now on, I'd like some of you to have a go at using the formula. So I think maybe not for these, maybe for the next lot I'll use the formula. But otherwise, you can stick to the 3 steps. Does exactly the same thing. Unpause when you're done. Yeah. Okay, we're done here. So let's do 1. Firstly, let's do add the parallel sides. Oh, sorry, it didn't actually say which ones are parallel, did it? Okay, well, if you were stuck by that, you can now pause and go back. Sorry, I think we can presume that these ones are parallel. Okay, 8 plus 4 is 12. Times that by the distance between them, which is 5, and that gets you 60. And then halve that to get 30 centimeters squared. Yeah. Number 2. Parallel sides are 3 and 5, so add 3 and 5 to get 8. Times that by the distance between them, which is 6. 48. There's my little blank spot, isn't it? The old 6 8s and 7 8s. Right, 48, and then halve it to get the area, which is 24 centimeters squared. Okay, let's move this one here. So 3. Add those parallel sides, that 8 and that 9, which is 17. Well, times the 17 by 8. I'll refer to my calculator here. 136. And then we do the 136 and we halve it. Come on, there we go. Sorry, it's a bit rubbish, isn't it? Which is 68. And we are working in centimeters squared. Okay, number 4. Again, add the parallel sides. That's 5 and 7. It's 12. Times that 12 by the distance between them, which is 6. So that is 72. And then we're going to halve it to get 36 centimeters squared. Okay. And let's move on. I hope you got those right. All good. I'm just double checking I didn't make any mistakes there. No, all looking pretty good to me. Okay, 4 more before you go off and do some cool practice. All right, I'm just going to mark on which sides are parallel, just because it's not fair otherwise. That's a right angle there. I think I'm going to presume that's a right angle. I've got a couple of parallel sides here. And that's parallel to that. Okay, unpause when you're done. Okay, now if you use the 3-step method, you'll still get the same answer, but I'm going to use the formula this time, just for those that are practicing the formula. Well, A and B, they're my two parallel sides, so I add those, 4 and 9, then times it by 7, and then halve it. Okay, so I'm going to put that formula into my calculator, and I get 45.5. I'm just going to double check that. Yeah, 45.5. And that's centimeters squared. That was number 5. Let's put number 6 down here. So this is this next one there. Area equals, again, I'm going to use the formula. 6 and 11 are my parallel sides. So I add those, times it by the distance between them, which is 8, and then halve it to see what answer I get. So that is an equal sign. I've just not drawn it very well. And then halve that to get 68. Why am I doing a degree sign? It's not degrees. Jeez, I think I need to have a coffee straight after this. Number 7, this one. The parallel sides are 4 and 7, so you add the 4 and 7, times it by the distance between them, which is the 3, and then halve it. So that, I'm just putting that into my calculator. It is 16 and a half. Okay. And the last one then, number 8. Well, 1 and 6 are the parallel sides, so you add those together, times it by the distance between them, which is 3, and then halve it, which I think is 10.5, but let's check it out. 1 plus 6 times it by the 3, and then divided by 2, equals 10.5. Now, whichever method you use, whether you use the formula or whether you use this 3-step thing, you are actually doing the same calculation. So as long as it works for you and you're getting the right answer, that's fantastic. Okay, I think now you're going off to Dr. Frost to do area of a trapezium. Please have a really good go at those questions. If you get them wrong, go back and check them, do them again. You can use either the formula or you can use the 3-step method. You can use a calculator, that's absolutely fine. And well done, and I'll see you next time. Bye-bye.